Welcome to this PanDao tutorial. In this video we're gonna show you the input parameter of our tool. We're gonna start by explaining the general parameter of a lens. As an example, we're gonna use this very basic lens which has two flat sides. First, we have to give our design a name. You can, for example, take the title from your drawing. You can find it down here. So we will add that to PanDao. Next, we can also add a description. Then we have to choose how many sides our design has. Here in our example we have a left and a right side. So we have to choose 2 here. Next we have to decide how many lenses we're gonna fabricate and in which batch size does it come. For this example we just choose 1,000 lenses and in 2 batches, so 500 pieces for each batch. Next we have to fill in the lens diameter. Here on our drawing you can see it here. It's 45 millimeters. So we're gonna add that here. And we also have to fill in the tolerance. Please note that PanDao uses absolute tolerances. So here we go from minus 0.1 to 0.1. So we have to add 0.2 here. We also have to define the center thickness and its tolerance. Here we have a center thickness of 5 and we go from plus 0.2 to plus 0.3, so we have a tolerance from 0.1. So we're gonna add that. Next we need the material. There are 2 possibilities to enter materials in PanDao. The first one is by supplier name. So here on the drawing we can see this lens uses NBK7. So we go to PanDao, set the material selector to by supplier name and add here NBK7 and it will show in the list. And PanDao will automatically fill in the material cost per volume, knop hardness, acid resistance and alpha value. It also knows if the material is suited for precision glass molding. If the material is not in the list, we can also choose a custom material. First we have to say what's the material type. For example, we can use ceramics or germanium or glasses. If we choose glasses, we have to fill in the material cost per volume, the knop hardness, the acid resistance, the alpha value, and if it's suited for precision glass molding or for molding applications by ourselves. Please note that PanDao only supports the most actual glass catalogs and old materials, for example as BK7, which contains lead and is not sold anymore, are not included. Next, I'm going to show you how to enter a flat surface to our design. We're going to use the same drawing for this. So we go back to PanDao and choose the first side. Here the shape is already selected. There are other shapes which we will see in the future part of the video. So we choose flats and the first thing we're going to enter is the clear aperture for the first side. So here the first side is the left side here. We can see the clear aperture here on top or also here down here. So it will be 40 for this side. We're gonna add that. Then we need 3 slash. We can find it in the drawing down here. And it's straightforward. So we have power here, 5, irregularity, and at which wavelengths. All down here in this table. So we're gonna add that. We have 5, 6, and the wavelength is already default. Next we have defect size. We can find it down here also in the table, and it's 0.1. Then the roughness we can find up here. It's P1. Okay, we're gonna go back and select it. We also can choose the roughness in nanometers per RMS if we like. And smallest mid-spatial accepted. Here we have nothing on the drawing, so we will set it to 0. For this example, we do have no coatings, no decenter because both sides are flats, and no cementing or facets defined. For the second side, it's also flat. The clear aperture is 30 here, or defined here. Then we go back. For power and irregularity, we have 2 and 4. Defect size is 0.4. Roughness we can find up here, it's P2. And no mid-spatials as well as no coatings or cementing or facets. Next, I'm going to show you which parameters you have to add if you have a spherical surface. For this, we're going to use this example drawing. To add a spherical surface to PanDao, we have to change the shape. If we change the shape, you can see that there are additional parameters appearing. The clear aperture is the same as for flats. Then we have to add the geometry and the surface radius. We can see in our example that we have a biconvex lens here. Please note that radiuses are always positive in PanDao. So we have here 50 on the left side and 30 on the right side. So we're gonna add that to PanDao. So here we have a convex geometry, and we're gonna add here 50, and then on the second side we also have a sphere, we also have a convex, and surface radius is 30. Then we have decenter here for this lens. So we can see it here, 4 slash decenter, it's 0.8. We're gonna add it here, fully specified decenter, 0.8. And that's it. There is no more parameters for a sphere. If there would be a spherical surface included, it would have been shown in the converter. And we also prepared an example drawing for this value here, which is also provided by the converter. So again, we're gonna change the shape in our drawing. The smallest radius, and on our example, we only have an Asphere on the second. Our handy tools. You can find the clear aperture again on the drawing here, or in the table below. Have to enter our parameters again. Here we have clear aperture of 40. I will copy them. And now we have to find the asphericity and the radius of removal sphere. and then get the result. So what's the asphericity and radius of removal sphere? We have the smallest radius of curvature is 40. So if you have concave parts included. We have this Asphere here, and now we want to try to fit the sphere as close as possible to the Asphere. You can see the Asphere here in blue and the best fitted sphere in red. And then the asphericity is the biggest distance between the Asphere and the sphere. So in this chart you can see it's here on the clear aperture, on the maximum clear aperture. This will be our asphericity, and the radius of removal sphere will be the radius of this sphere. So now how do I get this? Normally this is not written on your lens drawing. So you can either ask your optic designer and use your CID tool, or we also offer a converter here, asphericity and radius of removal sphere, to enter your Asphere parameter here. To speed things up, I already entered them. You can find them in the drawing, in this table here, for example, and the radius and conic constant you can find here. So if we then ask our converter, we get our asphericity here as in micrometer, it's around 4 millimeters. We add this to PanDao, and also the radius of removal sphere. The smallest radius of curvature we can also get from one of our handy tools. Just press here, and then we have to enter our parameters again. I will copy them. And then get the result. So here we have the smallest radius of curvature is 40, and there are no concave parts included. The next parameter we need to add is sagitta. You can find a description from the sagitta in our manual. Just press here, up here, manual, and then this will open. And here you can see the sagitta value for different shapes. For example, here A is something what corresponds to somehow to our drawing, right? It's the like from the maximum to the center thickness, right? There we have the sagitta. So if we go and check our drawing, this would be around here, right? So when we go to, there is a sagitta table normally on the drawing here, and we can see that with about around 14 millimeters, here we have the biggest distance of 1.635. Okay, gonna add this to PanDao. Another new parameter we can find on this drawing are mid-spatials. We can find them here. So for this design we should have no more than 0.08 minutes of slope. So we need to convert that into mid-spatials. To convert that we also need the irregularity. We can find it here, it's 1. So we go to PanDao, and then we can open one of our Pro Optics converter, slope to mid-spatial wavelength. We will have 0.08 here and 1 irregularity, and then we get the mid-spatials, and we copy this to the mid-spatials field here. And with that, our Asphere is fully specified. PanDao also offers a lot of options to customize your result. Next, we're gonna talk about the Options tab. First, in here, we have the applicability and level of maturity of the technologies included in the result. Standard is in industry and established. For these two options, you can find machines and personnel on the market. If you change here or you add, for example, R&D and emerging technologies, then you will also find technologies in the result which maybe only from one company can be used or maybe are still under development. Next, we have the wage level. The wage level determines on which location your design is fabricated. You can find a list of it in the manual. For example, high wage companies are normally located in, for example, Germany, France or Switzerland. Medium wage companies are maybe in Romania, Bulgaria or Serbia. And then low wage companies are, for example, in China or Indonesia. Be careful, maybe if you have a vendor in a big city in China, it's probably more a medium wage company than a low wage company. You have also the possibility to customize this yourself. Just set this level here, and then, for example, you can add your own bank interest or daily working hours. The next option is to enfold molding. So if you set this tick here, only molding technologies will show up in the results. With the next one, you can allow or disable block fabrication. For technology selection, normally this is PanDao default. If you purchased our company own or company specific option, you then can here change these options. So if you have company owned, for example, only the technologies you own will show up in the results, or even your company specifics. If you have one of these, you are allowed to force technologies. So example for this one, we want to force CCP bonnet to be in the result for side 1. We also have the possibility to exclude technologies. Just enter the name here from the technology you want to exclude, for example, CCC bonnet, and then ignore the technology. And then it will be ignored in the result. This may lead to a result where your design can't be fabricated. So be careful with this option. Please check it before you make some more requests. Thanks for listening to this tutorial. If you have any questions, please leave a comment below.